we can get started about what this workshop is all about and why I am here and what I do and what topic is going to be, right? We can probably get started with that. Okay, first of all, my name is Raghavendra Ural. I work as a developer evangelist for Intel. And my primary role is to talk to developers, talk to, it could be entrepreneurs or startups or companies about Intel IoT, specifically IoT products. We were doing workshops, roadshows across APAC and PRC. I'm responsible for APAC and China, but my team actually supports all these activities across the globe. So as part of that, as part of this role, we have been doing workshops. In the past, we have done workshops on Intel Galileo, Intel Edison, and all these stuff. So now today's workshop is going to be on the newest product that is launched 2 months back, which is called Intel Duel. Okay, so I'm going to walk through. My presentations are going to be like, first I will introduce you to Duel. It might sound like a marketing, but we need to know what we are going to look into, right? So we need to have a background of what product it is and how you can leverage in your product if you are trying to build, okay? So just before we get into the details, how many of you are from embedded background? Okay, there are quite a lot of people. And by the way, I'm not from the embedded background. To be honest, because I work as a evangelist from the solution perspective, where I don't go deep into how each module communicates with each other. Okay, so I was a software developer, and then moved into this role, and I'm now kind of enabling, and I'm kind of a bridge between developers and the product teams. Right, so in case if you have some kind of requirements or questions, or if you want to enable something with the product that Intel is doing, you could probably reach out to me, and I will be able to bridge between the product team or the enabling team with your products. So that's what I do generally. Okay. So now it's a challenge to start without the projector, you know. No, they don't have that cable. They have only HDMI cable right now. So the other cable they are building, they are bringing, and I don't have a HDMI converter. So without the projection, it doesn't make sense. So let's just wait for 2-3 minutes. Hopefully they will come by then. Otherwise, I will probably take my presentation and put it into some other laptop and try to project it from there. Okay, we'll probably wait for 2-3 minutes. So there is a quick announcement. While we are waiting, there is a goodie that we are distributing for all the participants from Intel. We were planning to do it at the end, but since we are already late to start, and on top of it there is a delay, so instead of taking time at the end, we will probably start distributing now itself. We will probably start the goodies distribution right now. Meanwhile, hopefully I'll get the cable. Okay, thank you. With all jugglery, with 3 laptops, we are finally able to get the presentation up. May not be the complete part. It is still cutting off some of the top and other things. I don't want to bother about that right now. Let's get started. Finally, what time we could start? 3:40. Okay, I'm just running late by 40 minutes. So I should be able to try and cover as much as possible. Okay, so as most of you may know, how many of you know Intel Edison? Right, so that was a quite popular model that came out in 2014, and it was like a system on module which with open sourced expansions, right? Like there are partners building expansion boards and all other things. And here what happened was we learned a lot. Right, we learned a lot in terms of how the developer kit should be, how the getting started experience should be, and all these things were the most key learnings that we had. So with that learnings, and with increased requirement to have more powerful edge devices, Okay, when we say edge devices, we tend to think in a regular home automation or industrial automation scenario. But when we say edge devices, there are so many different incidents wherein you need to have a powerful, like for example, if it is augmented reality or virtual reality kind of applications, or if it is drone, or if it is like autonomous robots, you need very powerful processing at the end. Keeping those learnings, we also want to take, we took some kind of objectives for the next generation products, right? It is like, how do you make, we want to make the performance as a first aspect, right, when building some of the next generation platforms. And we want to make it easy. How do we make it easy? It's only through making the developer experience simpler, right? I mean, you should be able to open the box, connect some IDEs, and build your application and get started. That should be the simplest approach to take. Then making it fast, right? We don't want the total time to market to go very long. For example, we came up with Galileo in the beginning, right? When Galileo came, though it was open sourced kind of board, still the time to market was very long, because if you want to do any sorts of modification and other things, it was taking a long time. How do we improve upon it? How do we add more ecosystem around it so that it becomes easy for you to build your own expansions, and then shortens the time to market cycle? Then making it your own way. It is very important. In the past, there have been a lot of feedback that we received from the market, is that you guys are restricting us to use only, let's say, Yocto Linux in case of Edison, and also in Galileo. And or you are restricting me to use only Wind River when it comes to gateways, right? That was the biggest feedback that we received across all the product lines that we had. So we took it seriously. Now we want to keep it open, right? People should be able to use whatever they want, whatever the operating system they are comfortable with, or their application needs, and we should be able to support it. And those are all the goals that we take it. And finally, make it real. I will keep it open. I'll go to the end and explain what is make it real means. Okay. With all these background, we introduced something called Intel Duel. Okay, you might have seen this in our booth. So this is the Intel Duel board, Duel module, with quite awesome performance at the edge, at the size. So this looks big right now. Let me just. So here, if you see, this is the Duel module, the one in the middle. I could have shown it in a much better way. I can probably circulate it later on. There is a small module here. That's the Duel module. And what you see with the expansion, with the IOs and everything, that's this is called Tuchek export expansion board. So if you look at the size of this whole module, and actually this is the size. It's a little bigger than Edison, but when I show you the comparison between the performance factors and other IOs and other things in comparison with Edison, you will notice there is a need for a little bigger space. So that's what we kind of accomplished here. Now, as I told you, we are trying to push performance to the edge. It is like, and the other thing is, of course, I will come to the actual the capabilities of the board. Before that, this module is certified, the pre-certified in over 80 countries. So generally, in your production line, right, the certification itself takes a long time. But this module, the antenna, everything is kind of pre-certified to be launched in 80 countries. We are trying to make concept to production faster by lowering all these other barriers of development cycle, like building your own certification and all these stuff. I'll talk about it in detail. And there is also a lot of SDKs, like how we did in Edison. We are providing a lot of SDKs, a lot of IDEs to help you build things faster. Where is the target? So obviously we don't want to put it like a where like you just want to control certain lights, and this is not going to be a fit at all, right? This is only for high processing needs, like where you need high compute. You should probably go for Edison. Duel. Now, vertical markets, what we are trying to look at it is like robotics, drones, microservers and micro gateways, industrial machine vision, and virtual reality and augmented reality areas. If you notice, they all fall under high compute areas like computer vision, speech processing, and autonomous behavior, some sort of machine learning and stuff like that, and complex motor control, data processing, and maybe audio processing. Okay, so to do this, we have this. I'll skip this slide. So to do this, Intel Duel comes with two models. Okay, so model 1 is with Atom processor, quad core. It's it's called 550X. It's at 1.5 gigahertz. Okay, and it's quad core, 3 GB of RAM, 8 GB of eMMC, and it supports Realsense Camera. Okay, I'll talk about Realsense in a bit, but it supports Realsense Camera. This guy supports Wi-Fi dual band, 2.4 and 5 gigahertz, and Bluetooth 4.2, 4K video support. Okay, and of course tons of other USB and connectors. And the 1.7 gigahertz, which is Duel 570X, is Atom-based processor with 1.7 gigahertz capability, 4 GB of inbuilt RAM, 16 GB of eMMC, and enhanced support for Realsense cameras and libraries. Okay, so which is going to be inbuilt into it, and rest of the things will remain the same. Now, where is the positioning of Duel and Edison? In Edison, it's like it's an entry kind of thing, like a strategy is to enter small form factor IoT spaces for prototyping and production. Okay, I could have got it today. There is, I got one drone built on Edison, which is currently commercially available in device. So which is used for, I think, survey and those kind of things. It's like drone is quite small, so you need to your hard module should be small enough to sit on top of it. So it's a small form factor thing, whereas Duel is like high-end system on module market, right? This is high-end stuff where I talked about high performance needs and other things. Wherever you have those kind of need, then you'll probably go with this. Then positioning is like performance, wireless, ease of development for deeply embedded developers. Again, come back to the 4K video. If you need a 4K video requirement and higher display, if you remember, Edison didn't have any display, and that was one of the complaint, right there. But we never targeted Edison as a device which will have a display or something like that. It was more like a wearable kind of use case, as you can see here, right? Where it should be there somewhere with a lower power thing. We should be able to run it continuously when you are wearing or things like that. Right? Wherever you have a real estate problem, there you used to use that. Now, in comparison, Edison was 500 megahertz. So you see this Duel is 1.5 and 1.7 gigahertz processors. That was dual core. These two are quad core processors. And they just had, there was no graphics with Edison. Had 1 GB RAM. Here you have 3 or 4 GB. 4 GB flash was there. Here you have 8 or 16 GB flash. You have USB 3 support. There are 2 ports. And PCI 1 ports. MIPI camera, MIPI camera, MIPI display. All these are available. And Realsense, though there were some use cases where people were able to enable Realsense camera with Edison, because Realsense came up with SDK for Linux. They were able to do something, but was not a direct or straightforward way of doing it. So here, because we have 3.0 support and the enhanced processing capabilities, Realsense is kind of inbuilt into it. And operating system, Edison had only Yocto Linux. Okay, but here we are giving you options to install whatever Linux that you, whatever operating system that you feel comfortable. So as I said, it is Atom processor, T series T5700 and T5500, quad core 64-bit processor, and it is based on 14 nanometer technology. So the performance, the power to performance mapping will be a little higher here, and it is dual band, and I guess I talked about most of them here. And you do have these pin mappings, because I don't want to go into the data sheets right now. It does have this on the go USB 3.0. Primarily we use it for firmware updates, nothing beyond that. And USB 3.0 and PCI Express must is there for any of 3.0 integrations. USB 2.0 with OTG support is available, and you have 1080p HDMI display, I2S, digital mic, and pretty much whatever is required for high performing need in terms of video, audio, everything is kind of covered in this particular module basically. .4K, maybe this is not updated, but it is 4K. It is 4K. We have Gen 9 graphics. We have inbuilt Intel, integrated graphics. It's there is a similar one from NVIDIA, I think, with the same performance or similar performance. I don't know the complete spec of that, but I think there is a similar one from NVIDIA. Right. Yes. That's what. So as I explained in the beginning, right? So we are trying to address the power and even the graphics, like Gen 9 graphic HD graphics is what we have integrated with, right? So it covers that those all VR regions basically, right? So this is the base carrier board that you need to currently is available, but other guys are building as we talk, right? There are DF Robot have built couple of base boards, and Easy Robot in US have built some base boards also. So the one that I am currently having is the base board, which basically with one OTG Type C support, and one Type A USB 3.0 support. If you want to add more cameras, for example USB 3.0 cameras or something, you need to have a hub with external power supply to it. And you have generic I/O connectors, like 40-pin connectors, and that one you can see the rails here. And it does have micro USB to serial FDDI debug port here, serial port basically, and SD card compliant, and you do have SD card support at the back. It kind of covers all the I/O requirements, primary I/O requirements here. Now all of those, the two-check board, the antennas, heatsink, SD card, and some cables, right? These are all kind of covered in the Duel Developer Kit. So this kit is available in the market to buy directly, right? And this kit basically contains one of these, like 570X or 550X. There's a price difference between the two. And all these expansion boards and Wi-Fi antennas, USB cables, heatsink, etc. will come along with the box. Okay. So right now in India, it's not currently available in the market, but I think by beginning of 27, they'll start listing in, I think, Moser or all those kind of websites. Right now it is available in Newegg and Moser in US, you can probably order and then get it, right? So there are some restrictions from the authorization or something you have. Okay, so the other thing was like lowering the barriers, like as I mentioned in the beginning, making it your own way. Right? Earlier we had the restriction on operating system. Now we use, and even we were using our own BIOS. Now we moved away from that, and we are using standard BIOS, which is UEFI BIOS, and there's a Linux kernel 4.4. It's available. Yeah. So there's Linux kernel 4.4. And on top of it, you can have, right now by default, it comes with Ostro Linux on the board. But you can download Ubuntu Core. Right now it is in beta, Ubuntu Core. I think they'll probably stabilize it by a month or so. Then you can download Ubuntu Core and flash it. Or any other Linux, like Xubuntu, Lubuntu. You can think about any of those Ubuntu families or any other Linux you should be able to distribute. And you can also have Microsoft Windows 10 IoT Core. And there is like getting started guide that Microsoft have put in for this. Now how can I reduce cost and time for a lot of activities which is not directly my IP or anything like that, right? So if you see the typical the procedure to bring a product to market is like you start with a concept, design your compute and communications and hardware, everything, you build it. Then you write your operating system level code and build custom carrier boards or whatever that you like. And then you need to certify. Okay, that's I think one of the key. So you need to certify before you deploy to a particular region. So after that, you write your app, and then you start selling it. So that's your typical life cycle of the product. Now with this, what we are doing is we have kind of knocked it off. Like developers don't need to do these activities. Like you don't have to do any of these activities. All of them are gone, and you basically would do from like, because of certification, because of rich operating system support and SDK support and other things, you don't have to do any of that. You will probably jump directly to rapid prototyping with the development module. You basically buy one and do your development. Then when you want to, you can probably go off and build a custom expansion board, and you are ready to go to the market with the product, because most of the certification is done. Does it mean that there is no certification, nothing required after that? No, right? The module wise, whatever we are covering in the module is certified. But if you are doing anything beyond that, which needs certification, you definitely have to go and get it certified. Okay, maybe it will reduce maybe 80% of your work in terms of getting all the certifications done. So FCC, CE, and those kind of certifications are all done, right? So any additional certification that you need in terms of your own module, you will have to get it separately. Okay, so this is a production module, right? So you can buy one, start your development, and when you are ready to deploy more, there is a channel to order more in bulk and then get it integrated with your system and deploy it. There are situations where you may be deploying it in certain temperature conditions or certain conditions which is not directly mapping with current Duel modules specifications. You can reach out to us. We are very happy to share what all the materials and other things, and we can even help you bring down the board design and everything. We can do it separately and then again go for deployment, right? That again we can do a mass production of it and give you the boards or the modules separately. Now I talked about making it real, right? So when I talked about it, this is what I meant. When I say making it real, how do I get the sensing capabilities, right? How do I get the sensing, understanding, and interacting capabilities, and also learning capabilities to your module? That is where Intel Realsense Camera will play a critical role. Okay, so Realsense Camera is this one. Okay, you might have seen this. This is like, it has depth sensing capability, and of course with RGB capabilities also. It can do a lot of things. I'll go to that. But our concept here is like, why we want to bring in a Realsense kind of capability is that by understanding what is there in the scene, what kind of objects, how they are moving, how they are interacting, right? By understanding that, it becomes more easier for your maybe robot or something to talk to the objects or interact with that object. So that is going to that experience is going to be totally different. Whereas if you don't understand what object it is, right? So that is what we want to bring in. And Realsense technology brings in the 3D depth sensing capabilities. For example, so it does real-time RGB depth and motion sensing together. Okay, so this camera, which is this is R200, it works in about 3 meter range. Okay, there are different SKUs that are available with different ranges, different capabilities. The one that works with Duel is ZR200, ZR300, which is basically it works in the range of 3 meters. Now this is like depth sensing. You can see the exact pixel matching that is done from the RGB to the depth, and you can even get the orientation and motions and other things. Then comes the depth reconstruction, right? Dense 3D reconstruction and scene understanding, right? This is the real picture taken using the Realsense camera, wherein you can see this is a cube set up in an office. You see a table, chairs are projected, there are people sitting in out here. These are all like 3D dense images created. So once the dense image and everything is created, you would be able to do the in-house GPS and external GPS kind of, which is called SLAM kind of things, using maybe robots or drones or anything like that. On the fly, they'll be able to understand the terrain well, or on the fly they'll be able to understand the internals of the house, where the objects are, how they are moving. They'll be understand, and they'll be able to move in the right direction and do the right things. Again, based on your application, how you build. And they works on like 6 degrees of freedom, DOF, tracking. And if it is a AR, VR kind of applications, the response of 6 DOF is in sub-milliseconds, which is very much required. If you go online, maybe YouTube or somewhere, you'll see some examples wherein in the augmented reality world with the headset or something people are wearing, and they are able to precisely touch the objects in the digital world through the physical hands, right? There were very good examples on YouTube. I would recommend you go and have a look at it, right? That's possible because of the sub-milliseconds response that you get on the orientation and everything, right? Which is very critical. Now, there are 3 critical things, right? Object recognition, person tracking, and understanding the locality, where you are and how I can move around. That's what we also do, right, as human beings. We do object recognition. We move around based on what we have recognized, whether I can go in this direction or there. That's what I do. And then I do person tracking, right? Whether this person is sitting, relaxed, moving around, and all these kind of things. So that's exactly what we did. One of them is the object identification is, as I mentioned, is one of those capabilities. So we have created database objects, database of objects like chair. For example, in my house, when I was testing this, it was saying wall power socket, right? So it was able to identify the power sockets also. I didn't train it. It was already there in the database. But apart from that, you can train with new objects into it. Then object localization. Where are my objects? Okay, knowing the object position, And then augment segmentation, right? It is in a, if you want to do, like, I take a picture of this, I see these two chairs, and I want to move this chair around to somewhere else. I just want to pull it out after the object is created. If I want to pull this chair around, then I need to know the exact projection of that particular chair. And that is exactly what it means by object segmentation. I should be able to pull it out and do whatever I want. Then comes the object tracking. If this chair is moved to somewhere else, I should be able to track the object throughout that movement, right, and find a new location and everything. So these are all inbuilt in the SDK of Realsense. Then next one is a person detection and tracking. So we can identify the person. So there is a difference between 2D and 3D camera, right? If I have a poster or something with a human-like thing, then it might, in a 2D camera, it might identify that as also a human being. But in case of a real 3D depth sensing camera, it can differentiate between 2D, like this is a poster or it's a human being, or it's an object. I can't say human being, because somebody, if they keep an idol there, then it might detect. Right? Then tracking the person movement and analyzing the postures, how they are sitting, whether like it's leaning down, left, or something like that. Then body part tracking and gesture recognition. So the one, that example says, like, if I do this, it will capture the movement, capture the point, and it will say it is directing to that side. Okay. Then expression recognition. It's a very good use case for retail, right, or in the fashion industry. When somebody walks in, and if they're happy, you might probably give different offers, right? If they are sad, it might project different offers, or it may give you some kind of, or even in case of music or something like that, right? You can change the music based on your mood. So those are all various use cases that we can talk about. And again, Realsense SDK is also available, which is a separate SDK, which comes with Duel module and Realsense camera built into it. Right now it is ZR300 is not available. Just in the testing, or not testing, it is still internally available, but it is going to be available by first quarter 2017. Okay, but the other camera, what I showed you is R200 camera, which pretty much everything else works except the SLAM. Right, it can't do mapping of the location and other things with Duel, but ZR300 will be available pretty soon. Okay, then we have libraries for all of this. SLAM libraries are available. Person library, it is again available in Windows and Linux. SDKs are available on both of them. Then object libraries are available, which is again open sourced, right? You can go to GitHub and download the whole source and modify if you want. Okay, how do I start? First thing is, like, we probably start ordering Intel module and developer kit. So one unit maybe. Then identify which operating system works best for you, right? If there are some DLL, something that you are using which makes sense to go with Windows IoT Core, go ahead and install IoT Core and start off. If it is, there are packages available in only Linux in open source community or something like that, then probably go with Ubuntu, right? Or you can go with Ostro, anything that you feel like. And install IoT Developer Kit, which will give you support for IDEs. If you are a Java developer, you get Eclipse kind of IDE. If you are a JavaScript developer, you get XDK kind of IDE, right? All these IDEs will be available, which you can use. Then there are a lot of information available online. If you go to software.intel.com/IoT, you could pretty much see all our boards and getting started on all of the boards. Okay, it is available. You can explore videos, examples, and share or ask questions on the forums. People should be able to help you out. Then if you feel like you need a new career board, whatever you have is not good enough, like to check board or something, then you can definitely go for building your own expansion board. Then finally, if the product becomes successful, obviously you need to order more. There is a channel through which you can order multiple numbers of GL boards. Okay. So in summary, um, so as I mentioned, so making performance is ubiquitous. So it's a small form factor with big performance, right? It's like small module, but you have a lot of performance. So you start with one unit, you expand it to whatever the numbers that you like. Then modular architecture streamlines the development process. Like you basically have module separate, expansion separate, and the development is going to be smooth and faster. And you choose whatever operating system that you like and the career boards that you want to. And there's a tight integration with Realsense, and it is not mandatory. Okay, you don't need to have Realsense, but if there is a use case which maps with Realsense depth sensing capabilities or those kind of capabilities that I talked about, then there's a tighter integration with Duel. So you can just get started and download the SDKs and other things, and you will be able to do whatever you like. Okay, so now we will see if we have the adapter. If adapter is there, then I'll be able to show you some of the demos. So I'm going to start with a getting started kind of thing. I will first try to connect the board to internet. Some of the steps which I have already done is pretty much like flashing the firmware, latest firmware, and all these kind of steps which I have already done. But I will start as a developer, right? I will go to Google, start searching for the documentation. Then I follow the documentation and get started. Afterwards, I should be able to show some other examples. First, I'll show the IDEs, Intel System Studio for IoT, which is for people who want to use C++. Then I'll show what do you call XDK, which is for XDK is for JavaScript developers. Okay. Then I will use 2D camera capabilities of Realsense. It's a RGB camera capabilities. Do a quick face detection using OpenCV with Python. So we are covering like JavaScript, C++, Python, and then we will also look at some of the Realsense examples, like object tracking and person tracking examples. Okay. You can be in touch with using the Twitter handle. So that's my Twitter handle, RAGURAL. If you have any questions, I'm pretty active on Twitter. So if there are any questions or anything, you should be able to send out a note to me. I would be very happy to answer the questions. Okay. Thank you. First, we'll go to Google and maybe start with a Google search. So it is going to be like Intel Duel So when I do getting started, so this will take you to, do I have the name? Okay, so it will take you to a page which clearly says software.intel.com / whatever Intel Duel getting started. But you can go to software.intel.com / IoT, where you can get to see all the boards that we are supporting. Okay, it will take you to getting started. Okay, so so that's a getting started guide that you have. So I need to do certain hardware assembly, which is like in the first time setup, which talks about how do you put this cooling, I forgot the name, what do you call? Heatsink, yes, sorry. So heatsink on the board, and all these things are basically covered in detail. How do you position everything? All these things, these steps are covered, which I have already done, right? So my board is already connected to the check board. Now once this step is done, then choosing the OS. So when I say choosing the OS, it doesn't mean that what OS I'm going to have on this. It's about the host OS. So if you want to, right now I'm going to use, oh sorry, this part is for host OS on this. Right now you have an option. Right now what we are showing here is Ostro OS or Windows 10 IoT Core. So I already have Ostro OS on this, so I'm going to skip this step. It is pretty much simple. You just have to flash it onto the SD card and get into the BIOS and change it to start from the SD card and then flash it. So it's a pretty straightforward steps which I have already done on my board. Okay, now once it is done, now I can start communicating with the board through the serial port. Now what I'm going to do is I'm going to power this up. Can you hear me? The back? Okay. So I'm going to use the micro USB cable and connect it to my to-check board. Okay, so if you notice, there is this micro USB slot. I have connected the board to this micro USB slot. Now let's try to get into the board. So we will use screen on Mac, but on Windows we can use putty, and the baud rate is 115/200. Okay. So that's my serial port. Okay, so I got into the board. Right now it is not connected anywhere. If I do ifconfig, okay, so it's not connected anywhere right now. So the next steps would be to enable it for SSH, sorry, connect it to Wi-Fi, then enable SSH. Right now it is serial, so later I want to do it over IP address. So that would be my would be my next steps. So let's go to that step. Now we do conman CTL. We use this conman CTL to connect to Wi-Fi. Let me try to connect. No, not really. Like if you have flashed Ubuntu, I can connect to keyboard and everything to this or with a normal screen. Then you can do with a normal Wi-Fi. Here I have connected through, I don't have, it's like I'm using it as a headless device right now, right? So there is no display to that, right? So that's why I'm using conman CTL to do configuration and other things. Then after that, I have to enable the agent. Okay, that's the Wi-Fi I'm trying to connect. Let's see if it goes through. Okay. I think I'm connected. I see IP address. Let's see if I can ping Google. Okay, now board is online, so I'm able to connect this board to the network. Now to enable SSH, in my board I have already enabled, but I'll just run through the steps. By default, the ports and everything will be blocked. People should not be able to get in, so we by default block the connections. To enable SSH, you need to run this code wherein you permit root login, because I'm logging it with a root here, so I need to permit that. Then I need to set some password. Okay, I need to change the password. Then I need to unblock the ports. Right now I'm unblocking all the ports, but when you are doing your actual work, you will probably unblock the ports that make sense for your application. So for that I used these IP table commands to allow, accept, forward, and all these kind of things. By default with Ostro it comes as blocked. The OS that we are providing, everything will be blocked. So you need to enable all of them to get started. Okay. So after that, we have MRAA and UPM libraries, which we have been using from quite a long time, and it's quite popular now. It's an open source library for doing core level or lower level interfacing with IOs. we use MRAA libraries. If you we have tested, we have built another layer of library called UPM. There is no full form for that, so don't ask me the full form. Okay, there is another layer called UPM, and this layer is like we have built about 120, 150 different classes or applications for different sensors that are available in the market. Okay, so you can directly start using the UPM, which in turn will use MRAA to actuate or get sensor data or something. You can go to software.intel.com/IoT, and then there is a sensor library section where we tell you what sensor it is, from who is a manufacturer, and sample codes we provide for pretty much everything. We have samples in JavaScript, Python, and C++. So you should be able to get started very easily. If you want that library to be installed on your board, then you have to follow this instruction. This is your middleware libraries that we talk about. Yes. So there are, it's not only Grow, we have tested with about more than 120, 150 sensors. Some are from Grow, some are from other companies as well. Right? This is sensor library basically. If your sensor, for example, you don't find a library in UPM, you have MRAA, you can directly build your own stuff on top of it. And again, you are not restricted to use MRAA or UPM. If you have any other library which you have been using, you are free to go ahead and install and use it directly. But the limitation with Ostro is that we don't have any package manager. Whatever you can do with wget or to git clone and other things, you can do it. If you need anything else, then you probably have to go with maybe Ubuntu or some such installations. Okay, so once this is done, then we will get into the programming. Okay, so here in this programming section, I'm only going to show you a couple of examples. I will only start with the hello world and leave it at that, just to show you that how do you do programming. Okay, on the board. So if you are a C++ lover, right, if you want to do something with C++, then you basically use something called Intel System Studio for IoT, which is free downloadable from the same place, software.intel.com/IoT. Okay, so here I've already installed the ISS. In short, it is called ISS, Intel System Studio. It is Eclipse-based IDE with our own plugins. Now here, if I go to the platforms, okay, this one IDE supports application building on all our platforms like Edison, Gateways, Duel, and Minoboard Max. Right now, whatever I have built, whatever I've connected to is the Duel platform. Let me go ahead and create a new project. So there are various options here, like I can create a new project from here, create a target connection. So that's why one of the reason I enabled the connection, SSH, is to have this connection built. Okay. Now if I go to the board again and see the IP address, okay, Duel. It will search, but it will take time. So I'm going to directly enter the details here. Okay, Duel 1 is my board. Let's see if I can connect. It is asking for password. I'll say root. Or did I say password? I'm not supposed to reveal the password, right? It's a super secret. But anyways, so now I've connected to the target. Okay, that is, I'm connected to my Duel board. Then I can import IoT examples. There are some example on which we have built in the past, previous example like access control or doorbells and those kind of simple examples. And Duel based code examples are also there. You can import any of those examples. Cloud based examples is also available. You can use any of them. Now I'm going to create the project directly. That's my Intel project. I'm going to use Duel board. C, C++ application. Distribution is going to be Ostro. We will be soon releasing distributions support. This IDE is going to support even Ubuntu. Yeah. 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 In Ubuntu, you are saying? Correct. Yeah. Exactly. So they have released a beta version about 15 days back. Okay, for Duel. So there's a version available, but it is in beta. Okay, you should be able to install and try. But I'm saying our connectivity with Ubuntu will be done, but it's not there yet. Okay. Now I select the Ubuntu, Ostro, and that is my connection where I want to push the code and try. Now it will ask to enter some detail, project name, and what's the template. Like I can start with the basic, like onboard blinking or something. Before that, it's already blinking because there is an application running. Let me kill that. Okay, now it stopped. Now I'll just say finish. It will create an application with all the dependencies and everything. And it is a pretty much Eclipse platform, so it will have includes and config, build settings, everything configured. So from the code perspective, it's pretty straightforward. It's again using MRAA library. That's a platform, and we will find out the platform type, and if it is Tuchek, then GPIO is 100, which is onboard LED GPIO. So if it is like other boards like Edison, it was always 13. This is 100 here. Once it is done, I just have to set the direction to output, and in a loop, write 1 or 0 to turn on and off in a loop, and sleep every 1 second. Let me go ahead and push this code to the board. I can do debugging also. I can do step-by-step debugging if I want, but I'm going to push this code directly and run it. Okay, so once it pushes, you should be able to see the blinking LED. I don't know, the people at the back may not be able to see, and my camera is not working. So there's a blink LED that started, and it will go on continuously. Okay, so now what I showed you is a very like hello world kind of thing, right? Same way you can use other example that I showed you, or you can combine multiple examples and build your applications very easily. You can even have an OpenCV application built directly from here and deploy it to the board and do step-by-step debugging or whatever you like. Okay. Now Okay, so previously we used, I think Eclipse came up with this Docker concept, right? Previously we used to deploy the applications directly with the images or toolchain and other things. Now everything is going to be installed on the Docker image, right? So we will only refer the Docker image, and then you just compile everything on the Docker image on the source and deploy the output to the board. Okay, that's what we have done now. Okay, so that's Eclipse. And are there any JavaScript developers here? No? Then should I show this or not? But anyways, okay. So there is a JavaScript IDE. If at all you want to build a Node.js application on the board, again, this is XDK. You go here and say start new project, onboard blink, continue, specify some names. I'll use some weird name here, create the project. Okay, the best thing about XDK is that this is, first of all, this is pretty old application which has been there from quite a long time. This is not only for your IoT application. You see there are two sections. You can build an IoT application, let's say a home automation you want to build. You can build a Node.js server and deploy it to the board, compile it, debug, test, do whatever you want. on the board. Once it is running, you can come down here and create a HTML5 based mobile app. Okay, so it's like a hybrid app. You build it, and you can do building, debugging, testing, everything on this the XDK itself. You can build the whole mobile app, which will interact with your IoT application which is running on the board. Okay, and this code you can deploy it into all major mobile platforms. It could be iOS or it could be Android or anything like that. It's one code which you'll deploy. But in this demo, I will only be showing the IoT part of the story. Okay, so here, this is the main area where you compile and build. So let me change this to 100. That's the port number, 100, and let's see if it works. So in XDK, it automatically recognized my board. I just have to select the board, say root, then connect, and I'm connected. Now once I'm connected, I can upload, then I can start. So you'll see the blinking again started. Now I can do step-by-step debugging of JavaScript also by using the option here. So I can go like Chrome type debugging, and then I'll be able to do everything. Okay, so I covered 2 IDEs, and the third one is Python, and there is no IDE from us. Okay, you are free to use whatever IDE that you have, or you are free to use normal text editor if you want. So let me log into the board through FTP for that. So while I'm talking, you are free to go and have some coffee. They said there is no break, so you can have a coffee in between. Okay. Sorry about that. I think 22 is the port number. I'll try to connect. Okay, so now I have done FTP into the board. So here, what I'm going to do is I have some Python samples. These samples are like, I have, I'm going to show 2 samples here. One is, these are all OpenCV based Python samples. One is live streaming of the camera output. It just streams, no activity or no detection, nothing. The second one is face detection on the OpenCV. Right? I'll just quickly do some sort of face detection with this. For that, I have to now connect my camera. This one. Okay, so I have connected my Realsense camera to the USB 3.0 port, and right now let's see what code I have written for this. So the code is very simple. I think that's the power of Python. So from the camera, I have a class called video camera, and I'm doing video capture too. So as I told you, this camera comes with depth as well as RGB camera. So the position 2, the 0, 1, 2, right? There is one more camera. There are 2 depth sensing cameras, 1 RGB camera. Okay, so the position 2 is usually the RGB camera. So I'm connecting to RGB camera. And I do get frame for streaming, and I do get face for identifying the faces. Let me show you what I'm doing with the identification. So I'm using this HAR cascade method to do the face detection. Again, this whole code kind of like the cascade file, everything is kind of downloaded from opencv.org. And I apply the cascading like multi-scale cascading onto this, and whatever the number of faces found, I'm going to display it on the console. And the same value, I'm going to stream it back to the connected applications. So where is the connection happening? Now if I close this, so I have two example live stream. It's a pretty simple. Whenever I access the URL, it's going to it's going to call this video camera. It's going to call this gen with video camera class, which is imported from camera. Okay, and there I start getting the frame. When I do the face detection, I'll start getting face. Okay, it's like I'm calling instances in the class. So let me try to run this. So that's the camera feed, and this camera supports 60 frames per second. So you see relatively very low lag in terms of the response, and it, by the way, it is reading the images through OpenCV and streaming it over the network. Then it is, for that it is quite quick. Okay. Then let's do face detection now. Okay, it's called find faces. Let's see whether it can find any faces. Okay, so it is identifying the faces properly. Yeah, you have been projected on the screen. So I just raise this camera to a little higher, and it kind of identifies all the faces in the picture. Okay. Yes. 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 No, 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 no. That is only for getting the IP address, setting the things and all. I'm running the application, and there is this. Okay, by the way, I can show you that part. If I go to find faces, so you see this response. There is a response object. I'm writing it to response. Whenever there is a request on my app, right, on the slash, that is on the root directory. Whenever there is a request, I'll read the images and write it directly to the response. So that's why you're getting the output directly on the browser. Okay, so that's what it is. Okay, you are still being recognized. Anyways. Okay, so it says whenever it finds, and this is the kind of output that it is getting, right? So there are two faces being recognized. Now let me cancel this. Okay, so that's what I wanted to cover in terms of IDE and 2D camera capabilities. So I can connect a regular Logitech 2D camera and do the same thing. I don't need Realsense Camera for what I have done just now. Okay, so let's see if I can run some Realsense stuff here. This is a 2D normal OpenCV example. It is not tracking the person, not tracking. Yeah, and also the Realsense examples that I'm going to show, it just counts the number of people, and it won't do the tracking, like whether this person went out and again came back, or those tracking are not yet done. I mean, the code is there. My example is not running that. Okay. Okay, let's see if I can run Realsense examples. So there are two examples. One is object recognition, another is person tracking. OR stands for object recognition. Um, one second. Okay, so these are all console apps. OR1 is for identifying the objects. Most of them are identifying the objects. It shows where exactly those objects are in the scene. Then person tracking is like PT1 is for counting the number of people. Okay, and PT2 is I think head pose. Like if I do this, turn around, it shows which direction you are in. And there is no UI right now. The next version which is getting built will have a graphic thing. Again, this is available online on GitHub. The next version is getting built right now. Once it is ready, you will have a UI screening that shows like where you are moving and things like that. Let's see if I can run tutorial 1 or 2. You can see it kind of identified those bottles, and it's saying some light. I don't know which light it identified. There is a table and a chair, some picture. Where is a picture? I don't know. Can we put this glass here? There's a bottle. I don't know whether it's the same. It's identifying that as the same bottle or something. Somewhere it find the wall socket or something. There's a cup. So it identified the cup as well. So like that, it keeps continuously identifying, and it gives you the confidence level. Right, 94% says it is a bottle. So that means depending on the confidence level, you can pick that object and say, okay, yes, this looks like a bottle. Right? If it is lower confidence, you can ignore that. Okay, so that's the object recognition part of it. Yes, internally, I don't know the algorithm what it is using. Right now, camera is not moving. Yeah. Which one? Mm-hmm. Yeah. Correct. Yeah. But I think the bottle has been pretty stable. 90 plus, right? 90 plus. Maybe we can improve by adding more. Yeah. No, no, no. By then it should have shown, right? It's not even before that. So it again depends on the kind of details that we have provided in the object when we are creating the object, right? I mean, we can train it little more training, it will probably give you more accurate results, like surf method, for example, right? Those kind of things. Okay, the next one I'll try to show you person tracking. By the way, there was one funny incident that happened that I want to share. I was testing this in the office, okay, and so whenever it was identifying like bag, like a chair, everything was perfect. It was identifying. But when I was sitting, it was continuously identifying a pillow. I was like, where is the pillow? I moved out and it was not identifying. You got the point, right? So there, there needs to be some more improvement. It cannot match human eye, is what I wanted to convey, right? That also indicated that I need to do more exercise because even the computer started identifying the pillows on the bodies. So that's an interesting stuff, actually. So on the person tracking, the head pose recognition, can you just tilt? No, yeah. 45-degree left. Just turn this way. Yeah, frontal. Or wait a minute, I'll turn it to my side. Okay, let's see. So it is like identifying right-left movements, right? So this will be useful, as I was telling in the beginning, right? We can identify the person and track what they are doing, whether sitting or posture recognition is also possible. There is one more demo which was I was not quite successful in running it, but I'll try again. Okay. I think this is. The field of view, if I don't have a proper UI, then it all I have to do everything with the guesswork. Okay. So it actually identifies my finger point and it will tell me where I am pointing, the position. Like you can see direction Y, and X is some position, and origin it starts from here to here or something like that. Okay. So like that, there are about right now. Yeah. So that's what with Windows IoT Core 10, if you install, then I think even some of those UI should work. Okay, but here also I think there right now the samples which are going to be out will have web-based UI, like how I did the streaming. Same way the outputs will be streamed, and you should be able to view it even if you don't have a display. Okay, so those were some of the demos that I wanted to show you. So in this whole session, I kind of, though we started late, we kind of I mean, we were managed to catch up at the end. So if there are any questions, I guess. Okay, so Duel SDK, the high-end one, which is 570X, is about $399, and the other one, I think it is about $340, which is 55X. Okay, Tango, Google Tango. Okay, I'm not explored it. Yeah. Okay. And I think the other thing is like it does have this integration with the Realsense and other things, which might add to the cost as well as the features. I guess in early 27 it should be available. In Q3, both China and India, like it was like somewhere in Q1 is what they were thinking. But again, depends on. Yeah. Yeah, all in place. I mean, that's not a problem. You can buy it and use it in India. Yeah. One is like the level of performance and the IOs and everything with the size is going to be different, right? Like that could be the primary difference. And it's like you have a proper backup from Intel because the company is driving this. The whole ecosystem is building around this, right? So that's another thing. Like, what if you should see for total cost of ownership also, right? I mean, today it's good. I mean, you can go with the low cost thing, right? When you give it to when go to production, if you start getting kind of issues or anything like that, who is there? Do we have a warranty support and all these things? Those all will play a critical role here. But Arduino, you should not compare it at all, right? Yeah, yeah, yeah. and also the integrations with all these 3D cameras and all these kind of things, right? As a bundle, this has a unique USP in terms of getting VR, IR integrated with Realsense and everything, right? There is a Bartender robot which they have demonstrated, which can identify who you are, and then it will say hello XY or something like that, and then it will start doing the activity for you. And there was another demo what they did is like it was done in IDF this year. Is like I think Boeing team came on stage to demonstrate the flight manufacturing process. They have different kind of bolts and nuts and all the dashboard and everywhere. It becomes very difficult for people to track everything. So they had an eyewear like this simple, and they had Duel somewhere fitted at the back, and Duel had proper connectivity with the central system as well. So, and there is like a display, and it kind of overlays on the actual plane or something. The moment you look at a particular bolt position, it will tell you what size of bolt, what you need to put it on their HUD display, right? And the number of bolts, number of patterns, and if you try to put a wrong one, it immediately identifies through the pattern recognition saying that you are trying to put a wrong bolt onto this particular hole. So all these things were built as a wearable, and that was demonstrated, and it is being used by Boeing for building it in the manufacturing space. Okay. Any other questions? Okay. Hope in spite of issues in the beginning, hope it was useful. You were able to get something out of it. Please shoot an email. If you can't ask me any questions, please tweet on my account, and I should be able to answer any questions that you have. Okay. Thank you.